right, so where's that 4 go in my equation? It's the outside, right? Because it's the starting amount. Right? We've always said that on the outside is your starting, your y-intercept right here. The multiplier goes inside, right? Now, in this particular example, they handed you the multiplier. But what if they didn't? How would you figure out that it was 3? Divide. Excellent choice. You would take any number in the chart and divide by the previous one. Good. Any number divided by the previous one. That's actually going to come up really handy in your future as well. You don't maybe know that right away, but how about that? How about that h of x? Something times something to the x. 8, good. And 1/4, good. Okay, so you're just putting those two things in. Obviously, in section 2, they took away, they made you come up with those values. But your y-intercept is important, and so is your multiplier. Anything else? Either in section 3.1 notes or homework that you want me to pull up? Yes? 3.1, number 35. Come on. See if it's at the end here. No, this is the wrong one. Okay. Oh, that's from last year. No wonder. Let's see if this happens to have it. 35, you said? Well, there it is. Okay. Use my other writing tool. Come on. So question 35 is it's giving me two different things, and it's asking me to solve graphically. So I'm guessing you probably want to say y sub 1 equals 9 to the x power, and y sub 2 equals 4 to the x power. Now, if I do this on my color calculator, the one that has, it's easier to tell on the colored version. For those of you who do not have a colored version, you're going to have to pay attention to whichever one is graphed first. Okay, so y1, let's see, 9 to the x, and y2 is 4 to the x. Okay, so let's see if I can get my, and they want 9 to the x. For me, that's the blue one. Okay. Let's get the old camera fired up here. Come on. If you're practicing with us, you're graphing. And we can zoom in on this. Oh, and they wanted what? They wanted 9. Oops, sorry, that's not what I wanted. I don't want to move that around. Oh, there it is. There it is. They wanted 9 to the x is less than 4 to the x. So for me, that's blue is less than red. Blue, for me, is less than red. Okay? So how do I want to graph it? Okay, probably want to go back to the standard window. I don't know what my current window's set at, so zoom 6. And maybe, we'll see, it might be more helpful if I get it more narrowed in, because it might look like it's, so, let's go window, let's change this to like, -3 to +3. And doesn't look like anything goes below the x-axis, so I might as well make my y minimum 0. Those are both exponential growth functions, so there shouldn't be any reason we're going below the x-axis. Neither one of them has been shifted down at all. So if I look at my graph, so there's my blue one, and we want to know when the blue one is less than the red one. Now, on the right side of my graph, is the blue one smaller than the red one? On the right side of my graph. So over here, is the blue one smaller than the red one? Absolutely not, folks. Those blue values are much higher. You can see that it's 9 to the x is growing much faster than 4 to the x. That side of the graph is not what we're talking about. You can see the blue one is bigger than the red one. Okay, so let me get rid of this, maybe redraw my window. Maybe I need to focus in on -3 to 0 and see what the left side of the graph is doing. So there's my blue one. Man, you can barely tell. I think maybe I'll have to even go down farther with my y min or my y max. Maybe I want to make that 3 and take a look at it. All I'm doing is trying to get a better looking picture so I can see that the blue one is there and the red one is above it. Now that happens to be the left side of the graph. How do you characterize or describe the left half of the entire graph? Ah, yes. -infinity to 0. How come my right bracket is not, or my right side of that interval is not a bracket? How come the right side of that interval is not a bracket? What happens right at 0? They're equal to each other, and this clearly does not ask me for where they are equal, only where 9 to the x is smaller than 4 to the x. Okay, so that's answer to 35. Okay, what's next? Homework? Anything in the homework? It's your time to ask me. Yep. 3, number 7. Whoa, too fast. Too furious. Number 7. Okay, what was the first thing I told you to do on all of these questions? When it says evaluate, what are you supposed to do? Set it equal to x. I told you every single time, make sure you do that. Okay? Hopefully I'm kind enough to do that for you on the test. But if it isn't, then make sure you do that. Okay, now what? If it's a single logarithm, is this a single logarithm? Just like the song says? Yeah, there we go. You did? And then you laughed at me? Good. Yes, I was in this. I don't know if I was at home or if I was here singing to myself. Okay. Next, what's the base? What's the base of any logarithm when it's not written there? Unless it says ln, and then you know your base is what? E, right? So that's all stuff we learned back in Algebra 2. 10, what's the exponent? X, right. This is your exponent. Remember, a one-word synonym for logarithm is exponent. That leaves me with only one thing left, which would be this, 10 to the third. So if 10 to the x equals 10 to the third, what does that mean about x? 3. Thank you very much. Okay. The bases are both the same already. I didn't have to do any algebra for that at all. I mean, it was kind of a gift-wrapped problem. Those are the kind of questions that should not be burning a lot of your time. Okay, you've got other things that will cause you, things that involve, rewriting things to a common base. That's where you're going to have to spend a little bit more effort. This, no. This should be, oh, hey, 10 to the x equals 10 to the third. Oh, yeah, x has to be 3. So, that should be a quick process. Yes? 34, sure. Log x equals 4. Okay, log x equals 4. Question 34. Log x equals 4. Is the left side a single logarithm? Yes or no? Yes. Oh, by the way, we haven't gotten into any of the tricky ones where we would have to use any of the log properties. That's in section 3, 4, and 3.5. So we are going to have single logs on this test. So let's see here. We got a single log. I guess it's ready. We're ready to change it to its exponential form. So what's the base? 10. What's the exponent? 4. And it equals the argument x. 10 to the 4th, that's a 1 with 1, 2, 3, 4 zeros. 35? Sure thing. Question 35 said log x equals -1. Now if we go through the same process we just did, something to the something power equals something, and we go through that, it would be 10 to the what? What's the exponent? -1, right? Equals x. And what is 10 to the -1st? What do we normally call 10 to the -1st? I'll take it as a fraction or a decimal. What do we call 10 to the -1st? What'd you say? 1 over 10, thank you. That's a good fraction version. Anybody got the decimal version? 0.1? Yep. I'll take either one of those. Oh, amen. A negative exponent definitely changes the base. It flips it over. Right? We tried our best to beat that into everybody's brains over a long period of time. So what would 3 to the -2nd be? Just out of curiosity. As a fraction, what would 3 to the -2nd be? Say it. 1/9. Thank you very much. Right? 3 squared is 9, obviously, but the negative flips it. So hopefully that helps remind you. Wait. Okay, well, if you want me to write it like this, 1 over 3 squared, I can. And then change it to that, I can. Does that help? Okay. 24 on that same page? Okay. So question 24 says e to the natural log 1/5. What do we do? According to Miss Bailey, we set it equal to x, and she is exactly right. Alright, now what? Change it to its log form. Since we're dealing with base e, what logarithm should I be writing? ln. Naturally. Okay, I know. Well, if it helps people remember, then I'll be dumb and stupid. Try to help people to remember. Naturally. So, and isn't it with a double L? Please tell me I'm right on the consonants. I don't remember. Okay, so naturally. Okay, I'm trying to remember natural, and then the phonetic E at the end. Naturally. Right, the natural log is base E. Okay, as soon as you see this, you should immediately be thinking natural log. Okay, so if you don't know, remember a logarithm is an exponent. So what's the exponent in this case? This entire thing is the exponent, right? The natural log of 1/5. That only leaves one thing left, x, right? And so x equals, what'd you say? 1/5. Nice job. Yeah, you can do that. That's okay. By rewriting it into its log form, the answer shows up quickly. Just like we did the other day in class a bunch. Yes, okay. Are you talking about the one? Okay, if you were given, maybe I should just pull up a blank piece of. Let me just pull up a blank document here, and then you can just tell me. Let's do this one. Ooh, I can use my lighter colors. I forgot that I switched it over to that. Fx equals 3 what? Oh, 3 to the negative 2x power. I apologize. Okay, I didn't understand. Okay, so what are they asking me to do? Okay, I want you to focus, those of you who are watching with me, I want you to focus on this right here. What is 3 to the negative second? 1/9, thank you so much. That is decay. Were they trying to trick me by writing a 3 right there, for which a lot of kids would say growth? Of course. That negative exponent causes the base to flip over. You have to pay attention to that. Otherwise, you won't realize it's decay. End behavior. So what does exponential decay look like? Well, everybody should know what exponential decay looks like. We don't need a grapher. If I just need a generic, if I just need to basically identify, so what's my limit as x approaches negative infinity of f of x? And then what's my limit as x approaches positive infinity of f of x? Yes, you need to know how to write limits, just like we've done from the dawn of creation. So, as you approach negative infinity, that would be this way on the graph. What's happening? It's going to positive infinity, yes. As you go to the right a long way, what happens? No. The asymptote. The asymptote is a function. Yes. Good question, by the way. I like it. But yeah, you don't need any kind of, super duper great picture for that. Just a basic generic decay function so you know what's going on the left side and the right side of the graph. Okay, next. Yep. Okay, 24. Did I not finish it or something? Okay, is e to the x the same thing as ln to the x? Well, one is an exponential and one is a logarithm. I want to be careful in how I answer this question. Like if I said y equals e to the x, and I said y equals those would be different functions. For instance, the one on the left here is an exponential. Is the one on the left exponential growth or decay? It depends on whether you know anything about E. Do you know whether that's larger than 1 or smaller than 1? It's larger, so you should know that that's exponential growth. But a log function, what does a log function look like? Every log function looks exactly the same. They are, remember we talked about how they were reflections across this line, y equals x? You have to know what a logarithm function looks like. So you should be able to tell me domain, range, asymptotes, but no, those two functions are not the same. Okay. Now you could ask me to say e to the x equals 5. You could ask me to change that to a logarithm function. I could solve using a log, and then I would have ln 5 equals x, and then that's something I can type on a calculator. But that's kind of a different type of problem than question than what you asked me, I think. Okay, question about this or something else? Okay. Yes. Amen. Would 1 over e be less than 1? Which means that if I asked you to graph e to the negative x, that is not exponential growth. That's exponential decay in disguise, right? So you should be looking at that going, oh, you're trying to trick me. I know that's decay. Right? Because exactly what you just said, that's y equals 1 over e to the x. And anytime, if you think about it, it's like 1 over 2.718. I'll just give you a very basic fraction that's close to that. 1 over 3, 1/3. Do you think 1/3 is smaller than 1? Of course you're going to say yes. Okay? So, does that kind of help? Yeah. Okay. Good question. Anything else on this, or you got something else for me? 51, can you tell me what it is? I'll just kind of write it out. This is 3.1, you said? Okay, so it's a chart of numbers. Maybe I should just look it up here so I have it in front of me. Okay. When did the population of Austin surpass 800,000 people? Okay, so Austin has so if you're doing, list 1 and list 2 in your calculator, so the years 1990 is considered year 0, and then the year 2011, that would be 21 years later. So that would be list 1 in my calculator. And then, obviously, for Austin, Texas, I'd have 465, 622, 465, 622, and 820,611. Okay, how do we come up with the equation that goes through those points? It is exponential growth, but how do I come up with that exact equation? Now, there's the Algebra 2 way of doing it, which is the brute force method. However, everybody in the room should know that this is 465,622. How do I know that? It's the y-intercept. It's what we just talked about, right? Okay, the big question is what you're going to get right there. Now, could you plug in 821 for x and 820,611 and then divide and take logarithms, blah, blah, blah? Yes, you could. Or what are we going to do with this thing? What'd you say? The exponential regression feature, right? You got list 1 and list 2, you better be using the exponential regression feature, right? That's under like what? Stat calc? All right? That's going to give you that other equation. And then, so we're going to call whatever we find there y1. What should we call y2? Because it says, when did the population of Austin surpass 800,000. So what I'm going to be doing basically, and of course we're looking at quadrant 1 only. Okay, so we've got this exponential growth function that's doing something like this, and then we'll have 800,000 coming through here like this. And we want to know that place right there. Okay, so we're trying to find that. How do we do that? Calculate intersect. Our favorite tool to use. Oops, I can't spell. I'm running out of room. I can't do this. Okay. But yeah, calculate intersect. That's the feature you're going to use from your calculator in order to find that intersection point. Okay? At this point, we're not going to do the brutal logarithm jump. Okay, we'll do that later. Okay, and you got another one? Yes. Now, if I were doing this and I was using a nice number like 0.75, I think I would change it to 3/4. Why would I do that? Because what is 1 over 3/4? Back in middle school, we said that 1 divided by a fraction is the same thing as 1 times the reciprocal. So we would just have 4/3 to the x. And 4/3, question, is 4/3 greater than 1 or smaller than 1? That's greater than 1, so I know this is exponential growth. So it is true that you could write 1 over 0.75, but the truth of the matter is, since it's such a nice number, you might as well change it to a fraction and then flip it yourself. Next. Yes. 5233. All right, what is it? What about it? What does it say? Oh, is this y equals this thing? Well, okay, f of x, same thing. Okay, so we want to put this in fireproof form. Fireproof form for a logarithm, going to look very similar to all the other fireproof forms we've ever done in our lives. It's got log here, and then inside here, if I can squeeze this in, x minus h over a. Okay, so changes on the outside must be affecting the y's. So how do I get those to move over to the other side? So we subtract 1 and divide by -3. Okay, so we got that part. Now, inside here, we always know that it has to be 1x. This is not 1x. Okay? Another way to write that would be -x plus 1. Now, what in the world could you multiply this by so that we could get 1x? What would you multiply this by to get that -1 to become a positive 1? -1. But if you do it to the top, you must also do it to the bottom. So that gives me x minus 1 over -1. So inside here would be x minus 1 over -1. So now you have, let's see here. We got 1 thing there, 2 things, 3 things, 4 things, 5 things. You got 5 things to tell me about that. Okay? Like we got a vertical stretch by 3. We've got a reflection across the x-axis. I'll just abbreviate x-axis here. We got an up 1, yes. We got a right 1. And we got a reflection across the y-axis. Man, this thing's like going crazy. I'm not sure I would have something that would have 5 pieces for you to do on a test. But if you can handle that, as I said, if you can handle our homework questions, you should be able to handle the test questions. I don't try to pick really impossible questions. I'll be here tomorrow morning if you have any more questions, and I'll post this along with all the things that we do in my 7th period class, which probably will be different than the questions you ask me.